Today I'm going to walk you through calibrating a no-tilt drill. Now every drill, depending on make and model, is going to be a little bit different in terms of the exact, parts of the drill and where they're located. But the general steps that we go through are going to be the same whether you're using a Great Plains or a John Deere or even various types of planters. So there are a few different tools that we need to complete this process. We need just a couple of buckets and pitchers just to catch seed out of our drop tubes and to move seed back and forth. We need a kitchen scale, nothing fancy, just need something with pounds, ounces, and ideally fractions of an ounce, so tenths of an ounce. We got a calculator. A paint pen is really handy for marking our drive tire, and you'll see why in a minute, and a tape measure. We're going to walk through this process as if you do not have access to your owner's manual for your drill. Obviously, if you have access to your owner's manual, you will be able to expedite this process and you won't have to calculate your working width or your drive wheel circumference or how many handle turns or how many drive wheel turns you need to do to simulate planting whatever a 1/30 of an acre. But we're going to assume that you don't have access to that information, and we're going to calculate all of this step by step just to double check and to be thorough. The steps that we need to go through to complete this process I've got listed here on the whiteboard, and I'm going to go through them and then we'll actually complete them on the drill. Step number 1, we need to figure out our drive wheel circumference. Step number 2, we need to crank our calibration handle. This drill has a calibration handle, though not all drills do, but this drill has a calibration handle, so we need to figure out when we crank that calibration handle one full turn, how many drive wheel revolutions does that equate to? Step number 3, we need to figure out our working width. Step number 4, we need to figure out how many linear feet we need to drive our drill to plant 1 acre. Step number 5, we need to turn our calibration handle, however many turns we figured out in this step, to plant 1 acre. And then step number 6 is we actually need to calibrate the drill. So we need to crank it, equivalent to a 20th or a 30th of an acre. And then we need to convert that ounces of seed that comes out of our drill into pounds to get us our pounds per acre or our desired planting rate. So step number 1 is to figure out our drive wheel circumference. Now I like to double check this every planting season. If the tread wears down or if the pressure of your drive wheel changes, that will change your drive wheel circumference, and that can quite significantly influence your seeding rate that your drill's putting out, even if your settings are all the same. So I don't have a flexible tape measure, so I'm going to use this phone charger and then hold it up to the tape measure to figure out what this drive wheel circumference is. So we're going to make sure we are nice and centered on our drive wheel, and right there. So our drive wheel circumference was 58.5 inches. I'm going to convert all of our measurements into feet just to make consistent units to help us complete the process a little bit easier. Now, step number 2 is to figure out when we turn this calibration handle 1 full revolution, how many turns of that drive tire does that equate to? It's not going to be a 1-to-1 ratio. Now, if your drill does not have a calibration handle, you can just use your drive tire circumference as a surrogate for the measurement we're about to get. So I've got my calibration handle in the upright 12 o'clock position, and I'm going to mark with my paint pen the exact top as best I can tell. I'm going to consistently use kind of the face of this metal brace that's holding my tire up. I'm going to mark straight across like this. And that is my starting point. Now what I'm going to do is I'm going to turn this calibration handle 1 full rotation. And there goes the mark I just made. And I'm going to stop in the same position that I started in. So I don't know what it's going to be, but that mark almost went around 2 full times. So now I'm going to mark again in the same spot as I marked the last time, even with this brace right there, straight across. and I'm gonna measure the distance between the second mark I made and the first mark I made. So here's the second mark I made. This is where the tire stopped after the rotation, and there's the first mark I made. So this tire traveled this distance less than 2 full revolutions. So again, I'm going to use my phone charger here to measure this distance, and we're going to take this over to the tape measure and transpose that. And that measurement is 12 5/8. So essentially, when I cranked that calibration handle one time, it produced 1 full rotation of the drive wheel and 12 5/8 less than another full revolution. All right, so now I've got to convert the measurements I just took to distance of drive wheel travel. So I'm going to take my original drive wheel circumference, which is 58.5 inches, 58.5, and I'll subtract the measurement I just took, which was 12 5/8, which is 12.625. And I'm going to add that back to the full rotation we got out of the drive wheel, which is 58.5. So 1 crank of the calibration handle results in 104 inches of drive wheel travel. So 1 crank of the calibration handle results in 104 inches of drive wheel travel, and I'm going to convert that to feet, divided by 12, and we get essentially 7 feet of drive wheel travel per 1 crank of the calibration handle. All right, now we've got to measure our working width. So we're going to do this manually. Like I said, we're going to measure from the top of the outside coulter, very top, to the top of the outside coulter. And that is 60 inches. Now, our outside coulter to outside coulter was 60 inches, but that is not actually our working width. We need to add 1 unit of row spacing to that. So our row spacing is 7.5 inches, and coulter to coulter was 60 inches. So our working width is actually 67.5 inches. And the reason we need to add 1 unit of row spacing to that is, think about if we're driving our drill in a straight line and then we turn around at the end of our row and make another pass right to the side of the first pass we made. There's 7.5 inches between our passes, and that carries throughout the entire field. So we need to incorporate that 7.5 inches into our working width. So our working width is 67.5 inches. So 67.5 divided by 12 equals 5.625 feet. Okay. So now we've got our drive wheel circumference. We figured out when we crank our calibration handle one time how many linear feet of drive wheel travel that equates to. And like I said, if you don't have a calibration handle, you just use your drive wheel circumference for that measurement. We figured out our working width. Now we have to figure out how many linear feet we need to drive our drill to plant 1 acre. So we're going to take 43,560, which is how many square feet are in an acre, and we're going to divide that by our working width of our drill, which was 5.625 feet. Okay, so that gives us, this is our width, and we're just trying to figure out our length, the length that we need to travel to plant 1 acre. So we're going to do 43,560 divided by 5.625 equals 7,744 linear feet we would have to travel, drive this tractor to plant 1 acre. Now the next step is to figure out how many times we need to crank our calibration handle to produce 7,700 or to simulate 7,744 feet of drill travel. So to do that, we're just going to take 7,744 and divide that by our drive wheel travel that we get when we crank the calibration handle one time. Like I said, if you don't have a calibration handle, instead of putting 8.7 here, which is what I'm going to put, 8.7 is our drive wheel travel per 1 crank of the calibration handle. Just put your drive wheel circumference in here instead of the 8.7. So we would need to crank our calibration handle 890 times to simulate planting 1 acre. Now I'm obviously not going to crank that calibration handle 890 times every time I want to calibrate this drill. I generally like to simulate planting a 20th of an acre or a 30th of an acre. If you only simulate, you know, a 100th of an acre because you don't want to crank your calibration handle many times, it's not going to be very accurate. And if you know, simulate a 1/10 of an acre, you're just going to have to crank it the more times. But the more you crank it, in theory, the more accurate it'll be. So we're going to divide this by, let's say, 30 to get a 30th of an acre. So I would need to crank the calibration handle 30 times to simulate planting a 30th of an acre. So I think that's pretty reasonable. So I'm going to take that. So 30 cranks doesn't plant 1 acre, it plants 1/30th of an acre. Now, like I said, let's just do this math just for people that don't have a calibration handle and that have a just a drive wheel instead. So if you're just spinning your drive wheel to calibrate it and not the calibration handle, all we're going to do is take that same 7,744 measurement from above, the linear feet we'd have to travel to plant 1 acre, 7,744, and we're going to divide that by our drive wheel circumference, which is 4.875 feet. 4.875 equals. That is 1,588 drive wheel revolutions to plant 1 acre. Now that's even more than the calibration handle. So if I wanted to get again to, you know, roughly a 30th of an acre, or to a 30th of an acre, I would divide that number by 30, and that gives me 53 turns of my drive wheel to simulate planting 1/30th of an acre. So that's all the preliminary math that we need to do to actually calibrate the drill. Now we're actually going to go ahead and calibrate it. So I've got a little bucket here, and I'm going to disconnect 3 of my drop tubes, and I use 3 just because I want to get a good average. There are 9 drop tubes on this drill, and I want to disconnect at least 3 of them, and I want to make sure there's all the seed out of it. I want to make sure all the seed is out of all 3 of these drop tubes. And then I'm going to put them in this bucket, like so. And I think they'll sit there like that. And then I'm going to go ahead and crank that calibration handle 30 times to simulate planting 1/30th of an acre. And keep in mind, it just so happened that 30 cranks turns into a 30th of an acre. It's actually quite convenient that it worked that way, but it doesn't usually. So I'm going to go ahead and crank that 30 times, and then we're going to weigh the seed that's spit out of here, and then we're going to figure out how many pounds per acre our drill is spitting out. Our desired seeding rate is 50 pounds per acre of wheat. So we're going to use our owner's manual over here as a starting point. Again, we're going to double check this because things change, drills wear out, drive tires change size, sprockets wear out. If we go to drive type 1 under wheat, here's wheat, drive type 1, our desired seeding rate is 50 pounds per acre. That means our seed rate handle should be roughly set at 60 right there, and our gearbox should be in drive type 1. So we'll walk over here, you go around that side. Our gearbox is right here. All drills are going to be different. Some drills you have to manually change the chain on the sprocket. This one has a gearbox, so I'm going to push that up to a 1, which is the lowest gear setting. And here is my seed rate handle. And according to the owner's manual, it should be set at 60. So I'm going to bump this over to 60 and make sure the slop is kind of centered right on 60. And I'm going to tighten it down. Now, all I got to do is crank this calibration handle 30 times, and we'll weigh the seed and convert that weight into pounds per acre. 3 on different drills have different settings and way to do this, but on most drills there are 3 ways to change the amount of seed that the drill is spitting out. Number 1 is your gearbox. Number 2 is your seed rate handle, so your seed gauge. And number 3 is your seed cup setting. Now these little brown tabs right here are to adjust your seed cups. And as you can see, when I move, look right in here, when I move this down, it moves my seed cup down. When I move it up, it moves my seed cup up. If I move it down, it's going to spit out more seed and enable the drill to spit out larger seeds. If I move it up, it's the exact opposite. So I rarely tweak my seed cup setting, but it is important that you always make sure that all of your seed compartments are set at the same seed cup setting. So I just got it, you know, kind of right in the middle there where it can spit out a variety of seeds. If you're planting, you know, corn, soybeans, thing with a lot larger seed, you're going to want to have a larger seed cup setting. If you're planting exclusively, you know, clovers, alfalfa, brassicas, etc., you're probably going to want to keep it on a lower seed cup setting so it's not spitting out too much seed. If you go really far on the extreme low or the extreme high end, just use this. This is for the small seed box, but just as an example, when you adjust that seed rate handle, it moves this drive shaft over one way or another. The more of these gears that are inside your seed cup, the more seed that's spit out. If you got to go really far to one extreme or the other, it puts a lot of stress on this, especially with older equipment, and it's not as accurate. Sometimes it's really difficult to even get this to go over to one extreme or the other. So I like to kind of keep it in the middle just to keep things a little bit more accurate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Alright, so I'm making sure that I'm shaking out all of the seed, just like I did before I started. So I'm making sure that seed is not getting trapped up inside my drop tubes. And I'm going to take my pitcher right here, put it on my kitchen scale. Make sure that my scale is zeroed out, and then dump my seed in. So that gives us 3.3 ounces of seed. Now, what I'm going to do is convert that to pounds per acre. So 3.3 ounces of seed was spit out by those 3 drop tubes. I'm going to divide that by 3 to get the average amount of seed that's being put out by a single drop tube. Multiply that by 9. I have 9 drop tubes on this drill. And I'm going to multiply that number by 30 because we simulated planting 1/30th of an acre. If you're planting, if you're simulating a 20th of an acre, you multiply it by 20, obviously. So multiply that by 30. Now, that gives me how many ounces of seed this drill is calibrated to plant per acre. Divide that by 16 to get to pounds. That is 18.5 pounds per acre of wheat. So that is really low. Our goal was 50 pounds per acre of wheat, and it is calibrated right now only to 18 pounds per acre of wheat. So obviously we've got some adjustments to do. So we can adjust our gear setting, and we can adjust our seed rate gauge, our seed handle, to tweak this number. Now, I generally like to have my seed rate handle, let's say the range is from 0 to 100. I like to have that setting somewhere between 30 and 70. All right, so following the owner's manual, now this drill is pretty old, parts are worn out, and probably they need to be replaced. But with our drive setting at 1 and our rate handle at 60, it got us to essentially 19 pounds per acre, which is less than half of what we're shooting for. So what I'm going to do is I'm going to bump up my drive to I'm going to start at drive 2 and keep the rate handle at 60, and we're going to rerun through this process and see what that gets us. So we're going to keep everything, we're going to keep drive at 2, rate at 60 again, and we're going to redo this and see what we get. Alright, so after we changed our drive to 2, but kept our seed rate handle at 60, we ended up with 8.8 ounces. So you're going to take 8.8, divide that by 3 to get our average per drop tube. Multiply that by 9 because we have 9 drop tubes. Multiply that by 30 because we simulated planting 1/30th of an acre. So that gives us our full acre rate. But that is in ounces per acre. We want to divide that by 16 to convert it to pounds. And now we're at extremely close, 49.5 pounds per acre of wheat. And our target was 50 pounds per acre. If we can get within, 5, certainly 3% of our target. I'm generally pretty happy with that. If we ran this again, we might be at 51 or 52. So I will run it again just to double check it, but I'm very pleased with 50 pounds per acre. So now our drill is calibrated at drive 2, seed cup handle setting at 2nd from the top, and our rate handle at 60. So I'll write this down in my notebook, and now I know that whenever I want to plant 50 pounds per acre wheat, this is the settings I need to use. Now I recalibrate my drills every single year. Things change, equipment's wore out. You know, if you're really on top of your equipment maintenance better than I am, you aren't going to have to do this as much. Things shouldn't change as much, but it is not uncommon, and this is by no means wore out, but you know, it's just an older piece of equipment. It is not uncommon for from one planting season to the next, my seeding rates to change, you know, 15 pounds based on what the drill's putting out. So even though my calibration settings are identical from one year to the next, and my target seeding rate is identical, it might put out 12 or 15 pounds more or less seed, depending on, you know, just, you know, slop in the equipment. So that calibration process is for our large seed box. Some drills have a large seed box and a small seed box like this one does. Now, on Great Plains drills at least, I can't speak for all makes and manufacturers, they're all a little bit different, but Great Plains small seed boxes, like where you put clover in this one and wheat or a cereal grain with a larger seed in the large box, this drive shaft on the small seed box is not controlled by that gearbox that I showed you a minute ago. Like the gearbox controls the large seed box. The only thing that controls the seeding rate on the small seed box is this handle right here. So the calibration process is exactly the same as you would go through for the large seed box, but you can't get as much adjustment out of the small seed box because it doesn't have the gearbox tied to it. It's just the seeding rate handle.